All right, nerds. This is chapter 10, section 1. We've got some questions about basic factoring and distribution. You got to start with distribution, so we're going to start with these, right? These are two binomials because they have two terms each, right? And they're multiplying because there's no sign in between, they're in parentheses. And we don't know when it equals 0, which is really easy when it looks like this. If one of them's 0, then the whole thing is 0. If I plug in 7 to both of them, I get 9 here, and more importantly, I get 0 here. 0 times anything, 0 times 9 is 0, so that works. The other answer is, of course, -2, because I can get -9 here, but more importantly, 0 here, and the whole thing's 0. Which is why we'll be taking some of these equations and turning them into this form, this factored form. But before you can understand how to get it into factored form, you probably need to understand how to distribute, right? Send it forward before you send it back. What we mean by that is that since there are two terms here and we're multiplying, we distribute over the two terms here. So x is going to multiply with both of these guys. We show arrows just to make that easier, but really what's happening is timesing both terms. If there were more terms, we'd times them as well. X times x gets you x squared, and x times 2 gets you 2x. Of course, we also have to distribute that -7 to both terms. So we'll end up with a total of 4 terms. This becomes -7x minus 14. And if you notice, these ones right here are like terms, right? They're both regular x's, so we can combine those. So we're actually going to end up with just 3 terms. And those 3 terms will be a quadratic term, x squared. We'll have a linear term because it's not squared in 2x minus 7x, which of course becomes -5x. And then we'll have a constant term because it doesn't have a variable, right? It's constant, so minus 14. And we can't combine those, so we end up with this, what we call a trinomial. Although at some point you just start calling them polynomials because poly means many. So this is the distributed form, right? The expanded form. It has 3 terms, and it came from this factored form that has 1 term, something times something. It's easier to solve the problem when it's like this, right? We solved it instantly. Asking this question, when does this equal 0, is pretty difficult. I bet you wouldn't be able to guess that 7 is an answer to this, or -2. And there will be 2 answers, of course, because the fundamental theorem of algebra says if this is the highest power, that's how many answers there will be. So eventually what we'll be doing is taking problems like this and working backwards to get this, right? And if you notice, what we'll be looking for are numbers here and here, and they happen to multiply to our constant, right? Because that's what happens here. And of course, we'll get this many x's and that many x's to combine to this many x's. So they'll add, these numbers will add to our linear term. That's a lesson for a different time. So right now we're just distributing. X goes to both terms, -7 goes to both terms. Combine your like terms, there it is. And we can solve it in this form. This one's another easy one. You'll notice here, hopefully, that the numbers here and here are opposites. So the same thing, but opposite sign. We call those conjugates. And while it's not super important to know this, my grandpa's name is Herb fact, it is going to be useful later on because conjugates do something interesting when you distribute them. And that's what we're going to find out here. Last time I distributed with blue for the x and green for the -7. But since these combine, I'm actually going to change my colors to show that these are the same thing. I wish these were the same color here, honestly. So I'm going to do that better on this one. I think it was good to do that for the first one, but we'll do that here for the second one. So let's turn up the brightness just a little bit and let's distribute. So, of course, x times x is x squared. That's what x squared means. I'm going to use blue for x times 4, which is 4x. And we know by now that we also have to distribute that -4 to both terms, right? I'm going to use the same color here, and that's because these are like terms, right? They're both x's. And if you notice, this becomes 0, and that's exactly what will always happen when these are the same thing but opposite signs, otherwise known as conjugates. And you don't need to memorize that, just obviously, right? If we have 4x minus 4x, it'll go away. So we're not going to have a linear term. We're not going to have that middle term. And then, of course, I'll use green for our constant. Looks like -4 times 4 is -16. So we end up with this equation. And when I combine like terms, I'll get that trinomial again. looks like x squared, nothing in the middle, 0 x's. I'm going to write this out just so you can see what's going on here. A lot of people just write x, and that's not the same thing. And we get this, which I'm going to draw a little arrow. This means 0 times x, just like this meant negative 5 times x. And 0 times anything is 0, so that's just nothing. If you put an x here, it wouldn't have a 0 next to it. That's 1 times x. That's a single x, just like this is a single x squared. So writing x is not the same thing as 0 x's. In fact, this is just nothing. It just becomes x squared plus nothing minus 16. It just becomes this. And if you notice, these are both square numbers, right? We have something squared, and then we have negative 4, right? 4 squared. We call this a difference of squares, or a diff of squares. Difference because we're subtracting. Squares because they're both square numbers, x squared and 4 squared. And so you don't need to memorize that conjugates multiply to a difference of squares, but hopefully you see why that is the case. In fact, let's cover this bottom part up just so it doesn't overwhelm you. Cool. So there we go. If we were to answer this question, when does this equal 0? This one's actually not too bad to answer from right here. A lot of people would tell me that x equals 4. Because, of course, we need this to be 16. So we get 16 minus 16 is 0. 4 squared is 16, so that's an answer. But there should be 2 answers, right? It's a quadratic. Fundamental theorem of algebra says there must be exactly 2 solutions. In this factored form, you can see that 4 is definitely a solution, right? We get 0 here and 8 there. 0 times 8 is 0. Over here, though, it reveals our other answer. We're forgetting the other answer, which, of course, is negative 4. Because negative 4 times itself gets you 16. So here are both our answers. You could write that like this if you want. Plus or minus 4. Plus or minus, right? Either or works. So there's our conjugates multiplying to a difference of squares. It has no middle term. And so eventually you're going to have to go from this to that. When there's no middle term, you know you've probably got some conjugates going on here. Or you definitely do, I should say. Now, most people feel pretty good about the last 2. It's really this one that starts making them sick. And it's because, well, we have fractions, right? Everybody fears fractions. But it ain't no thing if you just proceed as normal. In fact, let's answer the question right now. When will this equal 0? The answer is obvious in this form. Negative 5 will make this 0, and it'll make this something else, but who cares? Negative 5 makes this 0, so 0 times anything is 0. The other answer is 2/5. See, right now fractions aren't so scary. 2/5 minus 2/5 is 0, and this is something else. 0 times anything is 0, though. So here are 2 answers. Now the question is, what does this distribute to? Well, so far so good. X times x is x squared. I'm going to use blue to show that this becomes 5x. So again, so far, so good, no big deal. And it's still not a big deal, even when we get to this fraction, because when this multiplies with x, just like 5 multiplied with x to make 5x, this is going to multiply to make negative 2/5 x. It's okay. It's okay. We will combine these because they're both x's, and I did them both in blue to show that. But right now, everything's fine. You might get scared here as well. And if you don't understand multiplying fractions, it would be a little scary. But if you understand it, it's super easy. This says take 5 and times it by this. Well, first of all, it's going to come out negative, right? We got a positive times a negative here. It also says times by 2 and divide by 5. You can times that by 2 and divide by 5. In fact, you can do it any order you want. If you want to times this by 2 first, you get 10. And divide by 5, you get 2, right? Or you could divide first. 5 divided by 5 is 1, and 1 times 2 is 2. Either way, you'll come out to negative 2. Multiplying by fractions is actually pretty easy. It's the adding and subtracting that's actually a little tricky, and that's what we're going to do here, right? To combine our x's. So just real quick, this is x squared. Over here, I can't subtract them because they're not like terms. They're not both fifths. That's 5, but it isn't fifths. And the way I think about it is I think, how many fifths are in 5? Because if I can think about it in terms of fifths, then I can actually subtract them. They have common denominators, common denomies. So how many fifths are in 5? Well, if you think about it, I need a number that when I divide it by 5 gets you 5, right? So the answer is 25 fifths. Check it. 25 divided by 5 is 5. I didn't change the problem. I just changed my perspective. That's what algebra is all about. If I combine these, I end up with 23/5 of x minus 2 equals 0. So there's our expanded equation. And of course, being able to find the answers from this is kind of tough, right? Knowing that -5 and 2/5 are the ones that make this equal 0. Which is why what we're going to do when we have a problem like this is we're going to try and convert it to this factored form. And that's, of course, coming up in the next section. So yeah, distribution's pretty easy. Multiply, right, by everything. If you want to combine like terms, well, they got to have common denominators. This last one, part D, usually is the hardest part, right? Because it's part D. However, like many times in this book, the last one isn't the hardest one. It just has something interesting to show you. So first off, you might think that these are conjugates. But they are not, because they're actually the same thing, right? They don't have different signs. If one of them was a +8, then yeah, they'd be conjugates. So we're not going to get rid of our middle term, and that makes sense. So the question is, what is going to happen? Another way to think of this is it's x minus 8 squared equals 0, right? So what happens when we have a perfect square equaling 0, basically? What happens when it's something squared? Not something times something else, but something times itself. Well, hopefully you can answer the question. It's 8, and only 8. Now, I said earlier, fundamental theorem of algebra says that there has to be two answers, right? This is a square. So how come we only got one? Well, this is going to annoy you. But we say 8 has a multiplicity, and I'll write it out, I guess, of 2, meaning that it counts twice. And it's because it's an answer to both of these binomials, if you want to think algebraically. But it's also because eventually this will be a graph of a parabola. And the reason it has two answers usually is because it hits twice on the x-axis. Those are our two answers usually, right there and there. But of course, there is a way for the parabola to only ever hit the x-axis once. And that's to do something like this, where the absolute bottom of the parabola, or if it's flipped, the top, I guess I can draw that down here, only hits it once. It comes in and out at the exact same point. And that must be what's going on here with our parabola, our quadratic. It must look like this when we graph it. It goes in and out at the same point. And that point, of course, will be 8. Here is when we have two different points. Looks like one positive and one negative. Anyway, you don't need to know all this to solve the problem. It says distribute. So we're going to multiply x to everything. X times x is x squared. And of course, we get x times -8, which will be -8x's. You'll also notice we get the same thing here. And of course, we get the same thing twice, right? It's the same thing times itself. So we get the same thing twice in the middle. That's interesting. And we get -8 times -8, which is +64. It's that number squared. Probably should have done that in green. Here, I'll trace over it. Two wrongs make a right. So when we simplify this down, we're going to get x squared. And these don't go away because they're not opposite signs, right? They're not conjugates. We get -8x minus 8x, which is -16x's, plus 64 equals 0. So it looks like this number will just happen twice. So it's going to be twice that number here, and it's going to be this number squared here. So if you see a pattern like that, something where it's this, I guess I could put a plus sign there, and do something like that, 2a and then a squared. If you see a pattern like this where it's something doubled and the same thing squared, it's going to factor back to that. But again, this is neither here nor there for now. So there are the first few, right? Distribute everything, get your like terms together, solve it in this form, not that form. We've got one more in the section that everybody had questions about, and it's a spicy one. It's one with a star next to it, so it's extra spicy. And you can tell why people had questions about this. If this were the problem, no big deal. Distribute x to both, distribute -2 to both. Answers are 2 and 5. But when I throw this at them, they freak out. I don't know. Let's use what we know to figure out what we don't know. Let's just pretend this is all the problem was. Well, we get x squared, we get -5x, we get -2x, and we get +10. I'd still have my x plus 3 over here. And they're all timesing, so I can do it in any order. It doesn't matter if I did these two, or those two. I just did the two that were next to each other. And this will simplify, right? We'll get x squared minus 7x is plus 10. And it looks like we're timesing that by x plus 3. So here's where people, if they don't get stuck right at the beginning, here's where they get stuck. They don't know what to do. I don't know what to tell them other than it's the same thing you always do. You're going to distribute every term into the other. So I'm going to distribute x squared into everything. I'll distribute negative 7x into everything, and I'll distribute 10 into everything. We know we're multiplying, so we get x squared times x. That's x times x times x. That's x cubed. We'll also get x squared times 3, which is 3x squared. So you can see this isn't going to be a quadratic. It's going to be what we call a cubic, because it has a power of 3 as its highest power. I'll also distribute the negative 7x, and I think I'll do it up top, actually. Negative 7x times x is negative 7 times x, negative 7x squared. Of course, if I distribute that to the 3, I'll get negative 21x's. And lastly, because there's 3 terms here, I also have to distribute the 10 to everything. So I'll get 10 times x, which is 10x, and 10 times 3, which is 30. And that, of course, still equals 0. There we go. I'll combine like terms. Now, unfortunately, my color coding was for those arrows. So you can see that the x squared went to 2 things, got this. The negative 7x went to 2 things and got this. And the 10 went to 2 things and got this. So we're going to have to actually look and see which things are like terms. Well, there's only one x cubed, right? So we have an x cubed. But you'll notice here we have pairs of x squareds, right? There's no other x squareds in the problem. 3x squareds minus 7x squareds is negative 4x squareds. Here, of course, are a pair of x's, right? Negative 21x's plus 10x's, that's negative 11x's. And then, of course, we have a plus 30, which is kind of all on its own. And here is our distributed cubic equation, or polynomial, you can call it. So again, this is a cubic equation versus this thing, which we would call a quadratic, right? Because it's square. Or you can call it a polynomial. Nomial meaning name or term, poly meaning many, so many terms. Now, solving this problem is pretty tough, right? When will this equal 0? What numbers? And there will be 3 of them that I can plug in to make this equal 0. It's hard to see, but it's the same as this, right? This came from this, and this is really easy to solve. Because we're multiplying, if one of these is 0, 0 times anything gets you 0. So all we have to do is make one of them equal 0. And one way to do that, of course, is plug in 2 for x. So we get 2 minus 2, which is nothing. 2 minus 5, which is who cares. 2 plus 3, which is who cares, because nothing times anything gets you 0. The other possible answer is 5. Well, that'll make this a 3. It'll make this 0. And 0 times don't care equals 0. The other answer, of course, is then negative 3, because 0 times negative 8 and negative 5 is still 0. All 3 of these will work in this equation down here. In fact, I'll check them right now so you can see that at least one of them does. And then we'll end this video. So x is 2 should work, so should 5, so should negative 3. But I'm just going to do 2 because it's easy to do. 2 cubed is not 6. It's 2 times itself 3 times. So 2 times 2 is 4. Times 2 again is 8. So we're ending up with 8. This, it says square your x. So if x is 2, we get 4. And then times it by negative 4. So we get minus 16. Here, take x and times it by negative 11. So we're going to get negative 22. And then here it says add 30. And if you look, this right here becomes negative 38. And of course, oops, I jumped ahead. 30 and 8 makes 38. So 38 minus 38 is in fact 0. So it does work. So there it is. There are the exercises that you guys wanted to see / had questions for section 1. I'll have another video